differential equations. At time t days after the start of observations, the number of insects in a population is n. Variation in the number of insects modeled by the differential equation. K constant, n variable, t equals 0 when n equals 0, solve. Okay, so from the original equation here, we just rewrite the original equation. We have to separate the variables, so we make everything with n on one side, everything with t on the other side. So we do that by multiplying or dividing by something. So here we multiply by n to the power of minus 3 over 2 dt, because on the left we cancel out, we have only something with n, this is what we get, and on the right we cancel out, we get something with t only. Okay, now on the left we use this power rule. What we get is n to the power of minus 1/2 divided by minus 1/2 using this rule, and on the right we use this rule. The integral of cos is sine, so it becomes sine but divided by 0.02 because of the chain rule, so we divide by the coefficient of t basically here. And don't forget the constant of integration c. So now we can simplify things a little. Divided by minus 1/2 is the same as multiplying by minus 2, and n to the power of minus 1/2 is the same as 1 over the square root of n. Okay, so here divided by 0.02 is the same as multiplying by 50. So just use your calculator. 1 divided by 0.02, you get 50. Okay, now this is the simpler general solution. This is still a general solution because we still have c. Now we still have to plug in the t equals 0, n equals 100. So we replace the n with 100, the t with 0, we can find the c. So if we plug in 0, this is sine 0, which is 0, so this whole thing is 0. So the c is just, from here, use a calculator, you get minus 0.2. Now we have the c, we have the particular solution. So this is the solution already, we can just leave it in this form. Given also that n equals this when t equals this, find k. So previously we know the particular solution still in terms of k. Now we replace the n with 625 and the t with 50, and we can find the k. So if you use a calculator, you get minus 2 over 25, and if you use your calculator from here, we get 1 here. Actually, just this part, we get 1. Okay, we don't want to use the decimals because we want to use the exact value. Okay, so actually you can use decimals, but use many significant figures. Okay, just leave it in the exact value, just in sine 1 radians. So now we finding k, so just add 0.2 to both sides, and then we can divide both sides by 50 sine 1 to get the k. So this is the exact value, not simplified, but if you want to use a calculator, actually we have to use a calculator here, you should use at least 3 significant figures, so this is the final answer in 3SF. Obtain n in terms of t and greatest value of n predicted. So previously we know this is the k in the exact value, not simplified. So if we want to make it, so we multiply both sides by 50k, we get this. So from here we will get 0.12, and we get 0.12 divided by sine 1. So 50k can be replaced with this. Okay, so now we're gonna replace, this is from the original particular solution, we replace the 50k with 0.12 over sine I, and then here we basically swap this root n and this whole thing. So we multiply both sides by root n, we divide both sides by this guy, so we get this, we swap basically, and then we square both sides and we get n equals something in terms of t. So this is already the n in terms of t, and to find the maximum value of n. Okay, so to find the maximum value of n, you just have to try the extreme values of t. Just try the extreme values of sine something. So sine can only be between -1 and 1. So just try replacing this sign with -1, and then with 1, and then with 0. Okay, just try 3 values, see which one is the biggest. So if you replace the sign something here with 1, you get the biggest value. So in 3SF 1210. Alright, I'll see you again next time.